In Minecraft, a good part of the late game content is accessed by reaching the end portal. These portals, which are located in strongholds, are a gateway to the end dimension. After you kill the Ender Dragon, another gateway spawns and gives you quick access to the rest of the dimension. In this part of the dimension, you can find end cities, which can contain a lot of powerful loot, but more importantly, elytras, which give you the ability to fly. But before you can activate the portal, you have to find it first. Eyes of Ender, which are made by combining Ender pearls with blaze powder, will float in a straight line towards the closest stronghold when used. If you've played Minecraft, you know this can be a long process for a couple of reasons. The first being a problem of resources. You'll need to find Ender pearls to make Eyes of Ender, which are hard to come by since Endermen only spawn when you don't need Ender pearls. The second reason is that a lot of the time, the closest stronghold to you is extremely far away, which further increases the resource problem since Eyes of Ender have a chance of breaking when you use them. In this video, I will show you how to solve both of these problems at once by using a little bit of algebra. You'll be able to minimize the number of Eyes of Ender you use to find the stronghold, and subsequently minimize the number of Eyes of Ender you waste. And if you're really lucky, you might only need to use one Eye of Ender. Okay, so what I have here is a website called GeoGebra, and you can access this by going to geogebra.org. The way you spell that is in the top left. It's like an online graphing calculator. But for our purposes, let's just imagine that this coordinate plane is just we're looking at the map of Minecraft from above. So what I'm gonna do is put a point here, point A. Now let's imagine our character is standing at point A. Okay, we cast an Eye of Ender, and it goes up over here and it lands there. Now what we can do with these 2 points is make a line. In this case, I'm going to do a ray because the pearl went in a certain direction. I don't want the line to go down here. But so we made a line using these 2 points. Now we know that because the Eye of Ender goes directly towards the stronghold, we know that somewhere along this line, the stronghold will exist, right? Somewhere the stronghold will be there at some point. Now we can use this information to our advantage. If we move a little bit away from where we casted the first Eye of Ender, let's say we move, we go a little bit, we follow the path a little bit up here, and then we kind of veer off a little bit over here, and we stand right here. Boom, point C. We cast the Eye of Ender again, another Eye of Ender in case the first one broke, and let's say it lands right here. So, second Eye of Ender lands at point D. We'll make another line using those 2 points, and boom. Now, like the first one, we know that the stronghold will be at some point along this line, and because we also casted another Eye of Ender earlier, where these 2 lines intersect is where the stronghold should be. Now, I will say, disclaimer, because of human error and various factors in the game, sometimes the Eye of Ender doesn't land exactly where it was in the air. The actual location of the stronghold will probably not be right at this coordinate. It'll probably be somewhere around it, but so you can just use 2 Eyes of Ender to find the general area, and then you'll probably need a third and a fourth one to do a little course correction once you get to this area. And once you're here, it'll be like a probably 100 block walk at most, but this will get you very far, and it's a lot more efficient than using 10 or 20 Eyes of Ender, which could all break. It's a lot more efficient than using that many to get to the stronghold. Okay, so here we are in Minecraft. I'm going to make a new world, and I'm going to put it on creative mode just because I can't collect all the resources I need in a time span of 2 minutes. But I'll let you watch the world generate, just so you know I'm not, cheating and putting the stronghold in a certain place somehow before the video starts. Perfect. This is nice, a nice flat area. So I'm just going to spawn myself a Eye of Ender, and then I'm going to press F3, which opens all these developer things. It just gives you information about the game. What we're interested in is on the left side here. It says XYZ. That tells you your coordinates. We are going to be ignoring that middle coordinate, which is the Y coordinate, because that gives you your height. So as you see, as I jump down these blocks, it is decreasing by 1. And the reason we're ignoring that is because, like I said, when we're using GeoGebra, we are imagining that we're looking down. So we only actually need 2 coordinates, the X coordinate and the Z coordinate. And because the Y coordinate is the vertical coordinate, we weren't seeing that at all when we were using GeoGebra. We were just seeing X and Z. So we will use X and Z to record our coordinates. Now I'm going to stand right here, okay? And I'm going to write down the X coordinate and the Z coordinate really quickly in Notepad. So it's Z 7.572. And yes, I highly recommend using the decimals. And Z negative 23.576. Okay. And I'm pausing it there so I can write it in Notepad. Now, I'm going to cast the Eye of Ender and record the coordinates of where it lands. There it is. There we go. And you probably can see that, I'm not directly under where it was. And that goes into that whole human error thing I was talking about earlier. I'm not at the exact spot, but I'm pretty close. But even a small mistake right here will change the line significantly enough so that when we actually walk towards the stronghold down there, it's going to be, a little bit off, but it'll be in the general area. So let's write down the coordinate for this. 9.964 is X. And then the Z is negative 35.512. Cool. So now what we want to do is go to a different area, somewhere that's pretty far away, doesn't have to be super far away, but just a good distance. Probably this ice will do. And I'm assuming it's going in this direction. Now I'm going to do the same thing we just did. Open F3, record the coordinates. So X 189.341. Okay. And Z is negative 159.665. All right. Sorry for the pauses. I'm just, like I said, recording my coordinates. Now we're going to cast the Eye of Ender, which did not go the way I expected. Oh, I think it was right here. Okay. So we'll write down these coordinates. So X 190.325 and Z negative 170.852. Okay, so we have our coordinates. And if you are following along in your own game, you can just pause the game for now, because all we're doing now is math in Notepad. Okay, so I have Notepad open here, and these are the coordinates I wrote down. So this is the first point I was standing at, and then this is where the Eye of Ender landed. And then this is the second point I was standing at, and this is where the second Eye of Ender landed. All right, so how are we going to make a line? First thing we need to do is find the slope of each line. Now we can use the point slope formula and plug in these points to find the slope. So point slope formula is y2 minus y1 over x2 minus x1. So for the first one, I'm gonna put M1 just so we know which line it corresponds to. So for the first one, it is negative 35 0.512 minus parentheses negative 23.576 and parentheses just because there's negatives flying around and that can get confusing for me at least. Second thing is the x2 minus x1, so we got 9.964 minus 7.572. Jeez. Okay. I think I got those right. So whatever that is our slope. I'm going to go ahead and do the second one as well. So again, slope is y2 minus y1. In this case, also, the y's, of course, are the z's because the y in Minecraft is the vertical axis, like I said earlier. So z kind of serves the purpose of y here. So y2 is negative 170.852 minus y1, which is negative 159.665. All right. And then over x2 minus x1, which is 190.325 minus 189.341. Now, those hopefully will yield different slopes. Now, if you were too close to your first point when you casted the second Eye of Ender, it's possible that you'll just get the same slope that you got with the first coordinates. So that's why you need to walk far enough away. And then also, for that same reason, you want to use the decimal places just to be a little more exact, because, you know, if the first slope is slightly different from the second slope, that matters. That way you can actually get the two different lines and they aren't parallel, and then you can find where they intersect. So I'm going to plug these into Google really quick. Okay, now we got our slopes. So this is what you want. You want slopes that are very different. This is very good. So this actually will just be very easy to find the stronghold, just because they're so different. Now, if they were very similar, it might be a little difficult to find the stronghold. Okay, now that we have our slopes, we are going to need to do another thing to get our lines. So the format for a line is y equals, or actually in this case, to be less confusing, z equals mx plus b, right? So we just got the m, so we will do, let's see, m1, which is negative 4.9899. That is the first one, and we still have this b that we need to figure out. And the second one, let me do z1, z2 for clarity. The second one is negative 10.3201 x plus b. Now, the b is where the line intersects the z-axis in this case. So, how do we find this? Well, what you can do, just plug in points, right? So what I'm going to do here is plug in, let's say this z coordinate right here. I'm going to put that there. And then this x coordinate, I'm going to plug it in right here. And then I'm going to solve for b. And that's it. So I'll do that. I got negative 23.576 equals negative 4.9899 times 7.572. And remember, I'm using those two coordinates at the very top there, right here. That's where I'm getting those numbers. And then plus b. And in order to solve for b, what I would do here is I'm just going to copy and paste this. Solve for b, you want to isolate it, which means taking this and subtracting it from the other side. Really, what you're doing is subtracting it from both sides, but you know, you subtract this from itself, it's 0, so that leaves the b alone. You subtract this from the other side, it's whatever this is, negative 23 minus this big thing. Now let's see what this actually is really quick in Google. So the slope is b equals 14.2075. All right. So what I'm going to do now is get rid of this work, since I need some room. Get rid of that. And I'll just plug this in here, actually, for z1. Boom. That's z1. Now, z2. is negative 10.3201 plus b, sorry, negative 10.3201 times x plus b. That's very important. Now we're just going to do the same thing here. Is plug in points from the second, one of the points on the second line, not using one of these points. This is the first line. This is the second line. That's important. So we will do, let's see, negative 159.665 equals negative 10.3201 times 189.341, and then plus b. And like before, all we do, I'm just going to shorten it this time. Move this to the other side. Boom. And since it's a negative, we will add it. Okay. So now we have this line, or this intercept there, and plug that into Google really quick, which gives that. Okay, so this is our b-intercept for the second one. Boom. Okay, so we have our lines, and I deleted some clutter up there so we have more room to work. So these are our two lines, equations for the lines. So the stronghold is, it's at a fixed point in Minecraft, right? So wherever these two lines intersect is where the stronghold should be. Like I said earlier, it'll be near there, probably not exactly there, but it'll be very close. So what that means is that when these lines intersect, they have they share a pair of coordinates, right? So one point on one line is also on one point on the other line, and at no other point on either line does that ever happen. It's just at where they intercept, where they share that point. So what that means is we can set these two equations equal to each other, assuming that the y coordinate is the same. Or, sorry, in this case, the z coordinate. So what we'll do is negative 4.9899x plus 14.20 75228. And we're going to say that equals negative 10.3201x plus 1794.3530541. Okay. All right, so first things first is to combine the x's, which I have already calculated what 4.9899 plus 10.3201 is, and that is 5.3302. And sorry, I forgot to say negative for that. So we got 5.3302x plus 14 point that equals 1794, whatever that. And now all that's left is to subtract the 14 from both sides. Okay. I lied. That wasn't all that's left. We still have to, so what I did was I subtracted the 14 from the 1794, and I got this number. And of course, when you subtract the 14 from itself, it's 0. So all that's left on this side is the 5.3302x. Last thing. This really is the last thing in terms of solving for x. We just need to divide both sides by 5.3302. That way we just get x on its own with nothing else. So divide this side by that, and then divide the other side by that. And that gives us x equals 333.973, blah, 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 blah. Okay, so we have our x coordinate. Now, like I said before, we know that these two lines only share one point. So that means that when we plug in this point, both of the lines should give us the same y coordinate. Okay, so the last part of this is plugging in the x coordinate to one of the equations. It doesn't really matter which one you plug it into, because like I said, they should give you the same coordinate. And I will plug it into both just to verify. But if you're doing this, you should only have to plug it into one. So we will use the first equation. So I'm going to go ahead and copy paste this x, and replace the x here with the copy pasted x. And putting that to Google gave us that. Okay, so that that means that that is our z coordinate. So the stronghold should be at x equals 330 or 333.97, comma z equals negative 1652.28. And the only reason I'm rounding down like this is because um, at this point, you know, one unit here is one block. So, you know, you don't really need all these extra decimals now. That only mattered with the slopes. So, all right. So, this should be it. But for the sake of completion, I'm also going to plug the x into this equation as well. So, do this. Just copy paste a little bit here. Plug that into the x. Boom. Put this into Google. And yep, Google gave me the same result. And if you don't believe me, feel free to pause the video and verify that. But it does give you the same z coordinate. So our stronghold should be at or near these coordinates right here that are highlighted. Okay, now that we have our coordinates, it's x equals 333 and z equals negative 1652, I believe. I'm going to spawn myself in an elytra and fireworks solely for the purpose of getting there. Whoops. Okay, now let's open this. So, yeah, there we go. Okay, so we're going to x 333 first. Which way is that? Positive x. There we go. Okay, we're there. And now go this way for the negative z. There's also a quicker way to do this. If you can use the nether to travel very quickly. So 1 block in the nether equals 8 blocks in the overworld. So what you can do is just put down a portal, a nether portal, wherever you are, and then divide your coordinates you got for your stronghold. Divide both those coordinates by 8, and travel to those new coordinates in the nether, the ones you just divided by 8, and then put a new nether portal there, and you should be at your stronghold coordinates in the overworld once you go through that second portal. But obviously I'm cheating now to get to that spot, so we're about there. Kind of. Okay, it's about right here. So let me just go ahead and get to the precise position. 333, right? 333 and 1652. So I want to make sure that I get to the right spot. Now that I'm in the right spot, I'm just going to dig straight down. 1652. It's close enough. All right, so just dig straight down, see if the stronghold's here. I don't think it is, but it should be close by. Yeah, it's bedrock. So, gonna get some more Eyes of Ender, and it should not take me long. Now that I'm close to it, it should not take me long to find the fortress. Or the stronghold, sorry. I keep doing that. It should be very close. So we'll go this direction. And let's see. Yep. Oh, nope. Not yep. I thought it went behind me. All right. There we go. Okay. See, I was getting afraid. I was like, okay, please, please don't make me look like a fool. All right, so it's back here somewhere. I flew past it a little bit. So let's see. We are about. Okay, this is about. I'll find the stronghold first, and then say how far away it is from our calculated coordinates. So it's right here. So the stronghold is below us, 100%. Now, this is about 200 blocks away. So my initial estimate of 100 blocks away is a little bit generous, but either way, this will get you very close to the fortress. Stronghold. What? Dude, okay, so I know it has to be here. Where is it? There it is. Okay, I just went past it. Okay, cool. So we've got our stronghold. And now, you will just have to do some exploring to find the portal because the eyes actually don't point towards the portal. They just point towards I guess the center of the stronghold. They don't point towards like a certain part of the stronghold though. So yeah, we found our stronghold. All right, so last thing before I end the video, I'm back in GeoGebra. Um, I'm just going to show you the difference between what I mean when I say there is human error involved, and that's why you can't get the perfect stronghold coordinates. So first things first, we're going to act like we record the coordinates perfectly, and we get the perfect lines, and then their intersection will be exactly where the stronghold is, like perfectly. This is like in a perfect world. Okay, so we cast the first the first eye vendor from right here at point A, and it lands right here at point B. So this gives us a line from point A to point B, and it just continues onward. And I'm going to color this red because we're going to be casting different lines later. So we do what we did in the video. We go some amount of blocks away. Let's say we go up here. This is about, probably about 75-ish, 80 blocks away. So we go over here, cast the second eye of ender from point C, and then it lands about right here at point D. Again, we make a line, and once again, we are assuming that we did everything perfectly. We recorded the perfect coordinates. We got it exactly right. Now, where these two lines intersect is where the stronghold is going to be. Because there is no error, the stronghold will be at this intersection right here. Now, we have these perfect points. We've got these perfect lines. So, realistically, let's just assume that we record our starting point perfectly, which, that's reasonable. You can do that. That's pretty easy. But the ender pearl, we mess up by a little bit. Sorry, the eye. We don't record it just right. It's kind of a little bit off, about 0.1. Okay, so we'll put it right here. Boom. Now, if we zoom out, okay, this is a very insignificant difference, right? It does not look different at all, okay? But we zoom in, it's kind of far away. But anyways, let's put a line from A to E. So remember, the red line is in the perfect world, and the line we're doing now is, realistically, here's what would happen. We would be off by a little bit. So we'll do the green line. So red is what would happen in perfect world. Green line is what actually happens. We'll zoom out, and you can see it's getting further and further away as we get further along. Okay, we're going, and I will speed this up a little bit. Okay, so you can see the two red lines intersect right here. But one red line and then the green line intersects way down here. So that is already, we've already messed up. So we're assuming one line is perfect and the other line is, a little wonky. Just with that, this line is about, I'm estimating here, it's about 100 blocks away already. Now, if the same thing happens, and, again, we don't quite record the landing point of the second eye of ender correctly. We, get off by a little bit. We'll say right here. I think this is about 0.1 away, maybe a little bit less. Anyways, so the second eye of ender that we cast actually lands at F. Let me scroll over here. It's going to be hard to do. So we'll do a ray from C to F, and we will color it green. Now, where the two green lines intersect, that's where we're going to go. Like in the game, that's where we're going to show up, and that's where we're going to dig straight down before we cast more Eyes of Ender to actually find the real one. So you can see, both of these lines are getting kind of far apart from their perfect counterparts, okay? So this is where our calculation, which is based on some errors, this is where that calculation takes us. Okay, it is about -675 and about 350. Okay, So negative 675 and 350. Now the true stronghold is at about negative 850 and 435. So that's about 300 blocks away. And you saw the error line was only like it's only 0.1 blocks away. It's not even a whole block away. It's literally a very small amount. So if you make any errors here, this is going to skew it by a lot. So this is why you need one eye of ender here. You throw it here, lands on E, and let's assume it breaks. You're going to need a second eye of ender for the second trajectory, and let's assume that one breaks. And finally, you go all the way to here, and now you dig down and you find there is no stronghold. So you got to go back up and use some more eyes of ender to correct your course, and hopefully you will find this pretty soon. So that's just kind of the idea behind why you probably need about 3 or 4 eyes of ender to actually do this in game. Hope you enjoyed the video.